Michael Montinomero, your presenter for today for Group 1, solving the second problem given by Mr. Ragol. And now, we have our problem here. A rectangular lot with one of its sides on a building is to be enclosed by 510 meters of fencing materials. What is the area of the biggest lot that can be fenced? So, given our problem, we can now proceed to our optimization process using the 6 steps given to us. So, step 1, represent unknown quantities as variables. So, for our given, we have 510 meters and one of its sides being enclosed in a one of its sides on a building. So, we represent, and since we have a given rectangle here, we can represent L as the length of the lot, W as the width of the lot, and A as the area of the lot. And now, proceeding to step 2. Giving and drawing the diagram of our problem, we will have here the diagram version of our problem. So, as we said earlier, one of the sides of this rectangular lot is on a building. So, this would be the diagram, and since you already have one of its sides is already on a building, we will only consider 3 other sides for it to be fenced by the 510 meters worth of fencing materials. So, we have here 2 widths and 1 length, and now we are complete with our diagram. Step 3, write the primary function and the secondary function for our problem. For our primary function, we have the required. We need to find the area of the biggest lot that could be fenced by the 510 meters worth of fencing materials. So, as we remembered, the area of a rectangle is length times width. So that would be our primary function for this problem. And our secondary function, which is the perimeter, and it is already given. Normally, we will use the formula 2 length plus 2 width is equal to perimeter. But since one of our lengths is already on a building, we will not consider this to be fenced, and now we will only have 2 widths and 1 length. So, we will have 510 is equal to length times 2 width. And considering that, we will now move on to our next step. In terms of one variable. Since it would be easier for us to substitute, to express the equation as in terms of L, we will use this to substitute this to our area. So, our given, again, 510 is equal to 2 width plus length. And subtract 2W from both sides, and we will have length is equal to 510 minus 2 width. And now, substituting this formula to our area. So, area is equal to length times width. Remembering length is equal to 510 minus 2W, we will have the quantity of 510 minus 2W times W. And simplifying it, we will have 510W minus 2W squared. And now, since we already expressed our functions in terms of one variable, we will now determine the domain of our function. In our area, we cannot have a value of 0 since no area can be expressed as 0. And since we already established the fact that no side can be equal to 0, no side can be half of the perimeter either, since it will leave nothing for the other side. So, in our domain, we will have W is less than or equal to 255 and greater than or equal to 0. This would be our domain. And now, proceeding to step 6, apply appropriate theorems. Since we already have our domain, and now we can now proceed to applying EVT or extreme value theorem. So, first, we know that 510W minus 2W squared is continuous on the interval W is
greater than or equal to 0 but less than or equal to 255. So, our next step would be to derive our function so that we can find the maximum value of our so that we can find the maximum value for our W. So, the derivative of 510W minus 2W squared, we will have 510 minus 4W. Set our slope to 0 and we will have 0 is equal to 510 minus 4W. Subtract 510 from both sides and we will have negative 510 is equal to negative 4W. Multiplying negative 1 to both sides and we will have 4W over 4W is equal to 510. And 4 divided and subtract, I divide 4 to both sides and we will have 510 over 4 or simply 127.5. And since 127.5 is in the interval, W is greater than or equal to 0 and less than 255, we can now say that 127.5 is our maximum for this function. And to get the area, we can now proceed back to our area here, 510W minus 2W squared, substituting 137.5, and we will have 32,512.5. Don't forget the units, 32,512.5 meters squared.